So we all know that in obstructive lung disease, the FEV1 FVC ratio falls below zero point 0.7, while in restrictive lung disease, the ratio usually stays normal or even slightly increases. But have you ever wondered why that happens? Let's walk through it step by step. A person takes a deep breath in and then exhales completely. The total volume of air exhaled is called the vital capacity. Now, if they exhale as forcefully as possible, that becomes the forced vital capacity or FVC. Now think about restrictive lung disease. Imagine something is limiting the expansion of the lung, maybe fibrosis or a stiff chest wall. In that case, the lungs cannot hold as much air, so both the vital capacity and the forced vital capacity will be reduced. In other words, the lungs have a smaller container size and less air goes in and out. But in obstructive lung disease, like asthma or COPD, the lungs can still fill with a normal amount of air. The problem isn't getting air in, it's getting it out. The airways are narrowed and that slows down how quickly air can be exhaled. Now here's the key part. When you exhale forcefully, most of the air comes out in the first second. That is called forced expiratory volume in 1 second. In healthy lungs, about 80 to 90% of the FVC is exhaled in that first second. And this fast flow comes mainly from the larger airways. When there is an obstruction in the larger airways, the airflow is slowed down. That means the FEV1 drops significantly while the total FVC might still be normal or only slightly reduced. As a result, the FEV1 FVC ratio drops, often below 0.7. In restrictive lung diseases, both the FEV1 and FVC are reduced, but they decrease proportionally. So the ratio between them, the FEV1 FVC remains normal or may even be slightly increased. And that's why the FEV1 FVC ratio behaves differently in obstructive versus restrictive lung diseases. In the next video, we will see other parameters that we can see on spirometry.